interfacing 8279 with 8085. The aim of the experiment is to interface 8279 programmable keyboard or display controller with 8085. The apparatus required to do this experiment are 8085 microprocessor kit, then 8279 interfacing kit. Now I am going to type this program. The starting address of this program is 4100 sub 4100. The first opcode is 2121. Next 2C. Next 41. The next opcode is 16 and then 0F. Like this we have to enter up to the address 4138. Now I am going to execute this program. I am resetting, then go starting address of this program 4100 and then execute. Now it is executing. The output of this program is the helpers in the display. Now it is clearly visible. We can also change helpers to some other data by changing these opcodes. Now the experiment is over. Interfacing 8251 or USART with 8085. The aim of this experiment is to interface 8251 interface board with 8085 UP. The apparatus required to do this experiment are 8085 microprocessor, then 8251 interfacing board. This is the program of the transmitter end, where we are sending the data serially to the receiver end. This is the receiver end program, where we are receiving the transmitted data. Now I am going to enter the transmitter end program. The starting address of this program is 4100. I am substituting sub 4100. Next, the first opcode is 3E. Next 36. Next D3. Next CE. Next 3E. Like this we have to enter up to the address, up to the last address. Now I am executing this transmitter end program. Go starting address 4100. The execution of this program instructs the 8251 to send the data 41 serially, and it also resets the system. Now I am going to enter the receiver end program. Sub. Now the address is 4200. Next, the first opcode is DB. Next C0. Next 32. Like this we have to enter up to the last address. Now I am executing this second receiver end program. Go 4200 and I am executing this second program. The output of this program is nothing but the 41. The serial data 41 is transmitted from the transmitter end to receiver end. To see the output at the receiver end, we have to look into the 4150 address. So already I have executed the two programs. I am going to see the output in the 4150. See, 41 is displaying in 4150. This data is transmitted serially from the transmitter end to receiver end. Now the experiment is over. interfacing 8255 with 8085. The aim of this experiment is to interface 8255 programmable peripheral interface with 8085. The apparatus required to do this experiment are 8085 microprocessor and then 8255 interfacing kit. Now I am going to type the program, which is taking port A as input port and port B as output port. This 8255 kit is having 3 ports, port A, port B and then port C. In this program we are considering port A as input port and port B as output port. What we are giving in the input port should be displayed in the output port after executing this program. That is our experiment. Now I am going to type the opcode. Sub, as usual we have to type 4100 starting address and then the first opcode 3E. Next second opcode 90. Next D3. Next C6. Next D, B. Next C0. Next D3. Next C2. Next the last opcode is 76 for halt. Next. Now I am going to execute this program. Go 4100 execute. Now the program is executing. So in the port A I am taking the 0 as inputs. So in the port B the output is all zeros. Now I am going to change the input value. One zero, 10, 10, 10. The output in the port A is like this. Now once again I am executing this program. Go 4100 execute. Now see the output in the port B. It is displaying as it is in the port A. Now the experiment is over. Interfacing 8255 with 8085. In this experiment we are considering port A as input port and the output for this program will be displayed in the address 4500. This is the program. Now I am going to enter the opcodes for this program. The starting address of this program is 4100. So sub 4100. The first opcode is 3E. 3E. Then 90. Then D3. Then C6. Next DB. Next C0. Then 3, 2. Then 0, 0. Then 4, 5. And then the last opcode is 76. Now I am going to execute this program. I am resetting and then executing. For executing, go 4100 execute. Now the program is executing. We are giving input in this port A. I am giving input as zeros. So zeros. The output for this program is sub 4500. So 00. What we are giving in the port A is displaying in this address 4500. Now the experiment is over. Interfacing 8253 with 8085 microprocessor. For doing this experiment, we need 8085 microprocessor, then 8253 interfacing kit and then a CR. This is the program. Now I am going to enter the outputs for this program. Substitute starting address of this program, that is 4100, and then next. The first opcode is 3E, then 30, then D3, then CE, then 3E. Like this we have to enter up to the last address. Now I am going to reset this program and execute this program. For executing, go 4100 execute. Now the program is executing. To see the output, we have to connect this probes in the positive in the third pin and the ground in the last pin. The positive is given to the third pin and the ground is given to the last pin. Now see the display of the CRO. It is showing a busy line. So the output for this experiment is, after giving 6 clock pulses using this switch, the output goes high for a moment. Now let's see. I am giving first clock pulse, no change, then second clock pulse, third, fourth, fifth, and then sixth, and then during the seventh, note down the change. The experiment is now over. Interfacing 8253 with 8085. The aim of this experiment is to interface 8253 kit with 8085. For this we need 8085 microprocessor, 8253 kit, and then a CRO. Now I am going to type the program. SUB 4300, the first opcode 3E, then 36, then D3, then CE, then up to 430C we have to enter all the opcodes. And then now I am going to execute the program. Go 4300 execute. The output of this experiment is just a square wave. See, a square wave is displaying clearly. This is the output for this experiment. We can adjust it by varying the time and voltage divisions. The experiment is over now.